Okay, so now what we will do is basically we will try to create or we will try to upgrade the cluster from HTTP 2.5 to HTTP 2.6. But prior to that, basically we do have a lot of requirements. Okay, so we need to first know. See, the thing is, whenever we try to do any upgrade, from one version to the other version, and also for the other backup and recovery kind of activity, we need to save the metadata information of our name nodes. Okay, both active name nodes or both the active names. So since they share the common metadata information since due to HA, so we can collect the FS image and edit logs from the active name node and put it into some remote machine basically. That is not the part of our cluster. Since we do the updates on our cluster, it may basically we may need to take the backup from somewhere and then again do the kind of rework if something fails. So for that, generally what we do is like we will have a network file system, NFS. Okay, so since the metadata information, or let's say some MySQL, if you want to save the databases. So basically MySQL is the database that gets used for saving or for having multiple components, metadata information like Ranger. We do have Hive, Uzi, Hive. There are multiple services which uses MySQL or any other supporting database like either PostgreSQL, or if you want to have something else in your cluster. But what we require is in order to create the backup of those databases, we require the data from MySQL as well as from some metadata information that is very crucial to run our cluster. So suppose if we do some kind of upgrade, and also in terms of doing the backup and timely backup of our cluster into some remote machine basically, so that is required. Nowadays what happens is basically to have, so we already have the high availability, we already have the HDFS replication factor in place, so that we will be in the minimum. I mean, we do not lose the data at all 100%. Okay, if some node goes down, but nowadays there is like kind of a DR cluster also, data that is disaster recovery cluster concept also has come. And in that what happens is basically we let's say if you have 50 node cluster, so you also need to make one more 50 node cluster and try to backup everything over there, and you can seamlessly switch between the PR, that is primary cluster, and the disaster recovery cluster. So PR and DR is the term that we use. So PR is where you primarily allow the users to access all the infrastructure of your Hadoop, and the DR is something that you have backup of everything, or just like kind of a sync between the PR to DR. So sometimes if something fails on PR, basically you will shift all your users to DR. Okay, or you can also keep a practice of, let's say 2 months you are working on PR and then next 2 months you are working on DR, so that there is not 11th hour surprises whenever your PR fails and you try to move into DR basically. So the connectivity and everything should work fine. Okay, so every month or every 2 months or every quarter basically you just try to make a switch between PR to DR. That is what is the practice being done. Okay, so for so PR DR, so the cluster preparation is same. What you just need to know, what is you need from PR to DR, you just need to do is like the copying of data from HDFS or Hive and Hive. So most of the time the developers or development guys are using Hive, and they may create new tables in PR wherever they work, no matter if they are working on PR or DR, but they start creating tables, databases, okay, pulling the data from somewhere. So data would be there in HDFS, pointing the Hive tables are pointing to that data basically. So both metadata and the data needs to be properly synced in both the clusters. So that is the practice. So towards the end of this course, basically I will show you some scripting of copying the data from one HDFS directory to the other HDFS directory when we work on Hortonworks. Now I think they are also coming up with a built-in functionality within Ambari itself, just to just to create the frequency and copying the data from whichever directory you want to, from your PR to DR. So in Cloudera, basically that facility is already there, given in the Cloudera manager, managed by the Cloudera manager itself. Okay, you just need to provide the name of the cluster and the sync frequency basically, and the data and all the metadata information will be synced between PR to DR and DR to PR back. Okay, Hortonworks Ambari is still lacking in that, but I'm sure, I think in HDP 2.6 there might be some facility, or they are working on it. Okay, because it's a scripting, we just need to provide the distcp. So if you want to do it manually, so we already know what is the distcp command. Distcp is like cluster to cluster copy. Okay, so you just need to provide you can create the script, pass all the directories that you want to sync between PR to DR in a file, and then it will be read by the script, and in that script it is just doing the distcp from one directory, from one cluster to the other directory in the other cluster. Okay, so data will be synced in that way. And then Hive database, you just need to sync, like just take a dump of MySQL from the Hive database and restore it on the other one, on the other database, and both the metadata and the data would be in sync, and most of the services will work. Okay, so we will see two things. One is try to create a NFS mount, network file system mount. So we will have this machine that is Mimant Active Directory. Okay, so that machine is not the active part, basically it is, though it is handling Kerberization and everything, but again it is not something that will hold the data for the cluster. Okay, so we can assume this machine to be a kind of our backup for some metadata, crucial metadata information, also some MySQL database dump. Okay, so we will first create that, how to do the backup basically. So we need to first follow this document and try to so on Active Directory we need to add a role called NFS. Okay, so first thing is that we will add a role called NFS. So we need to go to tools and manages and add roles and features. Do next, and from here we need to select that NFS. Okay, so we need to come here on file and storage services. Inside that we do have one file and ISCSI services, and inside that we do have server for NFS. Okay, so you just need to select and service for network file system management. Okay, so saying 8 features, do next, and restart the service if it is required. Okay, so let it install. So server is getting restarted. Okay, so server is restarted now, and so installation is in progress. So installation succeeded for the feature of network file system management. Okay, so we are good. Now we need to create a folder, let's say Linux backup. Okay, so this is on the desktop, and NFS share it with root access. So let me just create this folder on the desktop of here. Right click, new folder. Let me make it like that. Go to properties and NFS sharing. So currently it is not shared, so manage NFS sharing and share this folder. Okay, so it would be then so to set the permission, how the users can, so we can just go all machines, read only, so type of access, read write. So root access we need to allow root access. Okay, so read write and allow root access. Why? Because from the Linux machine we will use the root user in order to save any document into that, right? So you need to do all this. Okay, then apply, click OK and close. Okay, now see, you will see that this kind of option, this icon has come, that you can this two green arrow, come and go kind of arrow. Okay, on Linux machine, that is our master machine from where we can take the backup. Okay, so here what we need to do is basically we will come and we need to install this NFS utils. It might be there already, but if not, then it should install it, because this NFS utils will have the client that can talk to that NFS file system that we created. So currently it is not installed, so let me just install it. And after that we can create a directory, let's say /home mimant10 backup kind of thing. So currently we do have mimant10 as the, okay, so mimant10 is having, mimant10 is the user, right? So currently I am logged in with that. So we have installed this. Now pwd, so we are in /home/mimant10 only, so we just need to create a backup over here, and kdir, okay, cd backup. Now you can put anything inside it, or basically what we can do is cd backup. So we need to mount this folder into our NFS now. Okay, and this is the command through which we can mount. So sudo mount -t NFS. So this is our mimant, it is the machine, that is our Windows Active Directory, and this is the folder on which we want to mount, right? And so this particular directory and this directory will now be then connected. So whatever you can put here will be accessed over here, and whatever you put here will be accessed here. Okay, so let me just copy and paste it. Okay, so actually we need to now start the RPC bind that was missing over here. Okay, so we need to check the status of RPC bind. So this service will help to connect to the NFS file system. And now this is actually linked with this one on the Active Directory. Okay, so if it is stopped, then make it on. Okay, and once we do this, basically now put anything and then you should be able to see. So currently let me go to pwd, cd, okay, so cd back not cd/home. Now some other user has done this read and write. Okay, cd backup, we cannot go into that. Okay, so sudo chmod, I'm not sure, let me just give the permission to everyone. Sorry. I create any document over here, so I will say new dot text. Write something and let's save it. Go to NFS and try to refresh and open this document, and you see this new has come over here, right? You can open and you will see the text over here. Are you getting me? So basically this way you can just now suppose if you want to take the backup of FS image and edit logs, right? So you just need to go and check where your FS image and edit logs are there. So you just need to go on HDFS, and from this config just put just check where is the name node directory basically. Okay, so ultimately you just need to copy all those over here on this backup, and everything will be stored on your network file system over here. Okay, and this is like kind of separate machine. You can then later on you can again map this to some different machine. Okay, because ultimately you know that what is the path where the backup lies, right? So basically on the Active Directory side, the backup is lying somewhere here. So if you want this particular mount point to be created on some other node also where you want to pull the backup from the Active Directory, that also you can do. You just need to map the things properly and start your RPC bind, and then the backup will be done, right? So this is what is called network file system backup thing. Now this is one way. I mean basically this is what I told you, just a sample file. But then if you can basically you can have this suppose from the name node master or or any other on this particular node. If you want to back up some more crucial metadata, then you can just put everything over here in the backup, and you will get the things out. Now, and this is general way to work on the production also. So basically it's good to have the network file system available, and you just can put you can also create a kind of a script that will run on the that run on some frequency, basically daily or weekly or whatever you want, and it will keep the sync, or it will just replace the data on the Active Directory from whatever data you want to send out there. And at the time of failure, at the case of failure, basically we'll just pull it back and restore everything. So that FS image you can just do like that. Now the other thing is to create the backup for MySQL. Okay, so again the MySQL backup also can be put into the same Active Directory in the same path over here. So here we will have a file in which all the commands that will, when you run, will create the ultimate copy of your MySQL database. Okay, so let's say we do have Ranger database, we do have Uzi database, we do have Hive database, we do have Hue database, multiple databases are there, then users also are there, then permissions and everything, every grant, every permission, everything, right? Everything will be taken as a backup from the MySQL and put it here. And then suppose if you want to move that MySQL server from one machine to other machine, just delete everything from one machine and install the MySQL server on the other machine, and just rerun this dump over there, so it will be automatically created. Okay, so let me just show you how we can do that. So currently we do have MySQL. If you go into MySQL root -p, and this is, if you do show databases, so these many databases we have: Hive, Hue, MySQL, Uzi. So MySQL also, it's a database, and inside it there are a lot of informational tables. Information schema is also one of the very important database. Then we have Hive, Hue, Uzi, Ranger, Ranger KMS, and then furthermore, suppose if you install more things like Zeppelin and all, whatever. If you have your personal databases also for where you are keeping the data within, so that also will be taken a backup, okay, as a backup. So let me just exit out of it, and what you can use, there is command called MySQL dump, right? dump. So MySQL dump, and then you just press enter, it will give that what are all the option you can have. So basically there is all databases. Okay, this is best option, because you never know that something get failed, so you should always have a backup of all databases. Okay, so you can do all databases, and then you can just get them into any file. So I will say mysql dump kind of thing, or let's say database dump.sql. Okay, so all the SQL statements that that has ever run on this MySQL will be copied into this one, MySQL database dump.sql. Okay, so I have so all databases, and then there is also one thing called event. Okay, so let me just show you that what are all the other options that we can take out of it. MySQL help. So there is something, so there are a lot of options that we can take, but that was the best one just to take everything. Okay, and there is something called ABCD event. So dump event, so basically it will tell you that what are all the things it has executed. Okay, so this events also is a kind of option that we need to take. Okay, so let me now take a dump of it. So whatever databases we have in MySQL, just put all databases and events, and we need to give the user. Okay, user would be root, and password will be asked, and I am going to save this in database dump.sql. I've given the password. Okay, so once you run this command, basically in this if you open this file database sudo vi dump, basically it is having all these statements from top to bottom to create everything again. Okay, so with all the data, so all the insert into and everything you will get. So suppose if you try to find something for ranger, since we just created it, so you will find that insert into db values, and you will find all the ranger entries over here. Okay, and you will have the database and everything. So if you see create database, if not exists ranger, so this is how whenever this statement get executed, it will again create the ranger database, and everything it will be put into that. Okay, so this is the simplest way of taking the MySQL dump. I mean, it's just like a dump. Okay, and what you can do is just now just save this into, so I will say copy this one into slash backup. And once you copy into the backup, basically this dump will surely appear here, and it has come over here. So it's almost like 32 KB. Okay, and then suppose now if you moved this MySQL, or suppose your MySQL is corrupted. Again, you have this last backup till the point that it was working fine. Or suppose if you want to move this MySQL database from this machine to some other machine. Okay, so you just stop it, or just uninstall it from here and install somewhere else. And let me just give you one simple query. So suppose if I want to create a table, okay, and that particular query would be like kind of saved in this, or whatever queries that got saved into this database dump.sql. Similar way, what we can do is create a file. Let's say I will say create db. Okay, create db.sql. Okay, and here I will write one command called create database. I will say new database. I know that this database is not yet existing in our MySQL, right? So just simple command, or simple MySQL statement. And now if you want to execute this one on. So I will just provide the root password, it will be asked, and just on the reverse side just provide this one. So whatever statements are there in this .sql, okay, will be automatically executed within this MySQL. Okay, so just assume that instead of this we have this complete file, okay, that is database dump.sql. So in that way it will create all the things again. Okay, you can just take this MySQL server from one machine to the other machine, and there it will just have everything. Okay, so let me run this. Give me the password, and it's now if you go into MySQL you will see that some new database also is there. So user root minus password, sorry. Okay, and now to show databases, and this new database is created. Are you getting me? So basically that is just the SQL statement. So is and SQL is so even this complete metadata information that is still that was there in the MySQL, it is in kilobytes. So basically even in the production also, if you are not using your MySQL for transactional database, like keeping more transactions over there, and just keep only the metadata information related to Hive, Ranger and everything else, basically it does not have that much data, that much space occupied. So 1 MB is more than enough. Okay, a few MBs are more than enough in order to just keep the backup. So this is complete backup. So this backup is one thing. Now just imagine that this new is there where we have file system, FS image database, or sorry, FS image backup. Then these two backups are far more enough in order to recreate your own cluster again. Are you getting me? What you just cannot store is the complete HDFS data. Okay, so there is no way to do the backup. Only if you are having PRDR arrangement, that is primary cluster and disaster recovery cluster, then basically yes, you can have the HDFS data backup also. But this is only the metadata information backup. Okay, so that is how you can go for the metadata information backup and have your MySQL stored, MySQL database dump taken and saved in NFS. Also your FS image and edit logs will be taken and saved as a backup on your NFS. Okay, so that is the first important activity before you will think on the upgrade. Okay, because upgrade is a very risky process. It may cause a lot of things to stop or misconfigure or corrupt maybe. So any questions?
One question. So in this session we are going to will not take the actual backup, correct? For all the metadata, we'll just directly do the upgrade, correct?
Yes, I mean we know that we can redo, but in the production basically you need to take, or you need to first this is just manually we have taken, but then you need to create a kind of a script and make it like a kind of sync on either daily basis or weekly basis, so that you know that okay, the backup is there. I mean, it is very important activity to take the backup of all the crucial metadata, all the MySQL or whichever database. So PostgreSQL also will provide you the similar way of taking the dumps and put it into the .sql and again run it back whenever you want to restore it. Okay, so since we are using MySQL heavily, I just shown you the MySQL, but then again most of the database they are having this kind of backup and recovery kind of things out of the box they are providing.
Okay.